I'm Matthias Fassl from the SIGCHI Helmholtz Center for Information Security, and I'm going to present our paper on exploring a user-centered security design approach for authentication ceremonies. Let's begin by clarifying what we mean by authentication ceremonies. So, end-to-end encrypted communication is susceptible to so-called man-in-the-middle attackers, and these attackers eavesdrop on conversation partners by making them use the wrong keys. And most mobile messages, such as WhatsApp, Signal, Telegram, provide us so-called authentication ceremonies so that users can detect these kinds of attacks. This slide actually shows Signal's authentication ceremony on iOS. There, people have to meet up and scan each other's QR code to verify the security of the communication channel. So, however, these authentication ceremonies have several issues. So, first of all, most users are not aware of them, and those who know that they exist have problems using them correctly or don't really understand the exact purpose. And also, there's always the issue of social friction, such as embarrassment for not exactly knowing what's going on. So, despite valuable prior research, these problems are still ongoing. So, we decided to try something different and design authentication ceremonies from the ground up. So instead of starting with a security mechanism, we started with the user's perceptions on authentication and then tried to match a security mechanism to these perceptions. So our design process included collaborative design workshops to get an idea how users imagine how authentication should work, then a security expert who selected viable conceptual designs, and then we used iterative storyboard prototyping together with users and a UX expert to develop these prototypes further. In the end, we used a mixed methods online evaluation to compare our prototypes with Signal's authentication ceremony. So this process resulted in 3 prototypes. First of all, a selfies-based prototype where each user takes selfies of themselves that shows a verification action. Then an ID card-based prototype where people meet up to verify each other's security card. And lastly, and most successful in our evaluation, a prototype based on a combination log, where users choose a combination they want to use to log the conversation. Then they lock the channel, then they get the notification that it's been locked, and then they need to share the PIN with the conversation partner. And then they use a secured channel or they meet up to so that the other conversation partner enters this access code, and then the conversation can continue. So when we asked participants what kind of attacks they thought these ceremonies protected against, we found that participants who saw the selfie-based prototype were less confident in its security than participants who were in the control group, and participants who saw the combination log-based prototype were more confident in its security. We can partially explain this with quantitative data. So while participants in the selfies-based prototype condition were convinced in the authenticity of the conversation partner, the prototype did not really explain how the process would secure the communication channel itself. On the other hand, the combination log prototype security was on the surface easy to understand for participants, even though they might not understand the zero knowledge proof in the background. The most important lessons we learned were that it's important to have clear expectations from participants. So they're not security or UX experts, but nevertheless we can gain valuable insights from their conceptual ideas. And also that misunderstandings early on in the design process can influence the prototypes throughout the process. For future design projects, we would be more specific about our choice of participants, and also increase our focus on iterative qualitative evaluation.